In this question, we use the integral test to determine if it converges or diverges. Okay, for the generic term, an is n squared over e to the n. To use the integral test, we let the function be x squared over e raised to x. Simply change n to x. Okay, now we need to show f is continuous, positive, and decreasing on the interval 3 through infinity. Look at this sum, 3 through infinity. So on 3 through infinity. Let's go for the continuity part. X square is continuous polynomial. E to the x exponential function is also continuous. So the ratio is continuous. So there is no question. How about positivity? So we are working on 3 through infinity. So in any case, x square is always positive and exponential function is always positive. So the ratio, so is the ratio. Okay. About the decreasing, we are supposed to find the derivative of this function, use quotient rule, and show that the derivative is less than 0 on 3 through infinity. Okay, they should prove the function is decreasing, but instead I want to argue in this way. X square over ex, the top is x square and the bottom is ex. Which one grows faster, x square or ex? Ex. Okay, for larger values of x, this one is bigger than x square. That means this function is decreasing because the bottom decreases faster than the top. So decreasing on 3 through infinity. Okay, now for the integral test, we evaluate the improper integral, in this case 3 through infinity of x square over ex dx. Improper, so we need to take the limit 3 through t, let t go infinity, of x squared over e to the x dx. So how to find this antiderivative, how to find this integral, and later we take the limit. We have quotient, there is no quotient rule. Can we make use substitution? In that case, the inside function are generally the bottom, x squared. No, the derivative of x is 1, but we have more, so it's not gonna work. Let me write in this way. Let's make this fraction as a product, 3 through t. Okay, x squared times, move this to the top, e to the negative x dx. Now we have a product and we want to use the integration by parts. Recall when we have u dv, antiderivative of u dv, that's uv minus integral of v du. So we're going to use this formula to evaluate this integral. Let me write this limit here. So we need to choose u and dv. So for this question, u is always the polynomial part, x squared, and dv is e to the negative x dx. Find du, derivative of x squared is 2x dx, and integrate both sides. B is e to the negative x, e to the negative x divided by negative 1 due to negative, so negative there, divided by negative 1 I put over there. Then uv, so x squared times negative e to the negative x, let me write in this way, negative x squared e to the negative x uv, and we have limit from 3 through t, minus v times du, and 3 through t, v is negative, so this becomes positive, v du, so 2x e to the negative x dx. Okay, that is limit t goes to infinity. We can evaluate this now, or let's do that later. Negative x squared e to the negative x from 3 through t plus this 2 can be pulled outside or we can leave inside. We got another product 2x times e to the negative x, so another integration by parts. So for this term we use integration by parts one more time, where u is 2x and dv be e to the negative x dx. Find du, derivative is 2 dx with respect to x, and v is negative e negative x. Okay, and another integration by parts uv, so 2x minus e to the negative x, so minus 2x e to the negative x uv from 3 through t. Let me write over minus integral 3 to t v du. This negative will make this positive, so 2 e to the negative x dx. So we need to evaluate this. Okay, so this limit t going to infinity will evaluate this integral, the values limits later. Negative x squared e to the negative x from 3 through t, we can pull this negative outside, negative 2x e to the negative x from 3 through t, and plus, let's evaluate this integral. 2 is 2, antiderivative of e to the negative x is negative e to the negative x. Okay, we've done a couple of times here. Antiderivative of e to the negative x is e to the negative x divided by negative 1. I am putting that negative over there, and we need to evaluate from 3 through t. Okay, same thing all over, 3 through t, 3 through t. So let's evaluate everything for upper limit t minus evaluate everything for lower limit 3. Okay, this negative, so upper limit part minus lower limit. Replace x throughout by t. So negative, I want to write here negative t squared e to the negative t minus here 2t e to the negative t, and this is in fact 2 times negative 1, so minus 2 e to the negative t. That's the upper limit part, replacing x throughout by t. Now the lower limit, replace x by 3, so negative 3 squared, not 9, this is negative 3 squared, that's negative 9, negative 3 squared e times e to the negative 3 minus 2 times 3 6 e to the negative 3 minus 2 e to the negative 3. Okay, that's the lower limit part, replacing x by 3. Now we take the limit. This part, lower limit, is in fact a number. Okay, this is a number, a negative, all of them negative, so this negative when we distribute becomes positive, positive, positive. So this is a positive number. Exponential function, though there is negative sign, these are always positive. E to the negative 3 is in fact 1 over e to the 3. This is a decimal number, positive number. So this part with negative sign is positive. And when t goes to infinity, e to the negative infinity, e to the negative infinity is 0. Okay, let me tell you, e to the negative t, when t goes to infinity, that's 0, because this becomes limit 1 over e to the t, and t goes to infinity, e raised to infinity is infinity, and 1 over infinity is 0. So this is 0, when t goes to infinity 0 times something, this is 0, same thing 0, 0, and distribute negative, we get a positive number. Okay, negative, negative, positive, so we get a positive number. It's a finite number. All I care is this number is less than infinity. I don't need to know exact number. This is finite. All that means this improper integral converges. In turn, this series converges.